Gravity isn't simply pulling things down. It is a distortion in the fabric of spacetime, stretching across the universe and shaping reality itself, from falling pebbles to the motion of galaxies. Gravity doesn't act in one direction. It exists everywhere at once, sculpting the architecture of the cosmos. Welcome to Mattermosaic, piecing together the universe, one discovery at a time. Today, we're exploring a truth that overturns our everyday experience of the world. Gravity isn't just down. It is woven into spacetime, shaping motion, orbit, structure, and even time itself. Gravity feels simple because we encounter it daily, but its simplicity hides a mystery that challenged scientists for centuries. Why does gravity reach across empty space? How can something invisible control the motion of planets and stars? Newton described gravity as an attraction between masses, a formula powerful enough to predict orbits and tides. But he admitted he didn't know how it worked. Centuries later, Einstein revealed something revolutionary. Gravity isn't a force. Mass bends the fabric of space-time, and objects move along its curves. Earth doesn't orbit the sun because it is pulled by an invisible rope. It orbits because the sun creates a valley in space-time, guiding Earth along a curved path. In this view, space-time is not an empty stage. It is dynamic, flexible, and alive. Gravity isn't a directional pull, but the geometry of the universe itself. This mechanism is even stranger than it sounds. Space-time curves in 4 dimensions. When you stand on Earth, you feel gravity, because Earth is bending space-time beneath your feet and pushing you upward against your natural path. Even in deep space, far from planets or stars, gravity exists. It stretches infinitely, never turning off. Gravity is also incredibly weak, trillions of times weaker than electromagnetism. A small magnet can overpower Earth's gravitational pull on a paperclip. But this weakness is essential. If gravity were stronger, stars would collapse, planets would shatter, and galaxies couldn't form. Gravity also affects time. Clocks run slower near massive objects and faster farther away, a phenomenon known as gravitational time dilation. GPS systems rely on Einstein's corrections. Without them, navigation would drift by kilometers each day. In the extremes of the universe, gravity becomes even more dramatic. Near neutron stars, it crushes atoms. At the edge of black holes, time nearly stops. Inside them, space-time curves so violently that all paths lead inward, trapping even light. Black holes are places where gravity wins completely, creating regions of space-time where our current understanding of physics breaks down. But gravity's story is not only about bending and distortion, it is about creation. Gravity pulled the first clouds of gas together, forming the earliest stars. It sculpted galaxies, arranged the cosmic web, shaped planets, and set the stage for chemistry and life. Without gravity, the universe would be a diffuse mist of particles drifting forever, unable to gather or ignite. Gravity also plays a role in the future of the cosmos. Will the universe collapse in a big crunch, expand forever, or reach a quiet equilibrium? Today, dark energy is overpowering gravity on the largest scales, pushing galaxies apart faster than gravity can pull them together. Eventually, distant galaxies will drift so far that their light will never reach us. Locally, gravity will continue its quiet work, holding stars and planets together even as the larger universe fades. Gravity, everywhere and always present, remains the universe's most patient architect. It reaches across time and space, binding what it can for as long as the laws of physics permit. It teaches us something profound. Connection is the natural shape of reality. Gravity isn't just the force that keeps us grounded. It is the silent structure beneath existence, shaping motion, light, time, and the formation of everything we know. To understand gravity is to glimpse the architecture of the universe. This is Mattermosaic, piecing together the universe one discovery at a time. If this sparked your curiosity, leave a like, share it with someone who loves science, and tell us what you want to explore next. Subscribe for more weekly journeys through the fabric of reality.